The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to Ocean Acidification Week 2021. My name is Michael Aquafreda, and I am a postdoctoral researcher at the NOAA Ocean Acidification Program. I will be moderating today's session, which is a community discussion around CO2 and seawater certified reference materials. We are so pleased to see that over 50 attendees are here with us today, and we look forward to you contributing to our discussion. If you have questions at any time during today's session, please post them in the questions box and make sure to use the @ symbol to direct the question to a specific panelist. You also could do @all if it's a broad question for everyone. If we don't get to everyone's questions, don't fret. We will be continuing our conversation on the Ocean Acidification Information Exchange, and a link to that will be dropped in the chat box very soon. Ocean Acidification Week is brought to you by 4 sponsoring organizations. First, GOA-ON, the Global OA Observing Network. Second, the United States National Oceanic and Atmospheric Administration, NOAA. Third, the IAEA OA-ICC, the International Atomic Energy Agency, Ocean Acidification International Coordination Center. And last, but certainly not least, the IOC UNESCO, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization. For those of you who are new to GOA-ON, it is a collaborative international network designed to address 3 high-level goals. The first is to improve our understanding of global OA conditions. The second goal is to improve our understanding of ecosystem responses to OA. And the third goal is to acquire and exchange data and knowledge that are necessary to optimize modeling for OA and all of its impacts. GOA-ON was established in 2012 with just a handful of members, but since then it has grown immensely. In a little less than 10 years, it has grown to over 900 members from 105 countries. If you're not currently a member of GOA-ON, please join us. You could sign up to become a member at goon.org. That's GOA-ON.org. GOA-ON is also made up of 8 regional hubs, and we will be hearing from all of the hubs throughout Ocean Acidification Week. GOA-ON is an active organization that offers numerous resources to its members. GOA-ON informs policy at the international level and is involved with initiatives such as the Commonwealth Blue Charter and Communities of Ocean Action on Ocean Acidification. GOA-ON also supports the United Nations Sustainable Development Goal 14, known as Life Below Water. Specifically, GOA-ON helped develop the methodology for SDG Indicator 14.3.1. providing guidance on how to measure ocean acidity and how to report that collected information. The data collected informs local and regional governments, as well as UN climate programs. GOA-ON also hosts a data portal, which provides access and visualization to OA data and data synthesis products that are collected from around the world and from a variety of sources, including moorings, research cruises, and fixed time series stations. We welcome all scientists to submit their data to the portal. It's really quick, it's pretty easy, and it allows greater visibility of your work. Additionally, GOA-ON offers its members scientific mentorship, scholarship, and trainings through its peer-to-peer program. The peer-to-peer program is offered to all of GOA-ON's members, and we encourage people to join as either a mentor or a mentee. If you're interested, please visit the peer-to-peer webpage and fill out the application form. GOA-ON's newest resource is a webinar series, which was established following last year's Ocean Acidification Week. We welcome your input on what topics you would like to hear about in future monthly webinars. If you have any ideas, please share those with the GOA-ON Secretariat, and you could reach us at secretariat@goon.org. But over the next 10 years, GOA-ON intends to go even further. GOA-ON has become involved with the UN Decade of Ocean Science for Sustainable Development, which will take place from 2021 to 2030. This ocean decade will provide a common framework to ensure ocean science can fully support countries to achieve the 2030 agenda. GOA-ON is so proud to announce that our proposal, known as OARS, Ocean Acidification Research for Sustainability, was recently endorsed as an official UN Decade Program. We actually had a OA Week session about the OARS program that just finished up a few minutes ago. If you missed that, don't worry, it'll be posted on YouTube in the next couple weeks. The OARS program is going to build on GOA-ON's existing work, and it's going to help us further OA science by enhancing capacity efforts, increasing observations, identifying impacts on marine organisms, and providing decision makers with the information they need to mitigate and adapt to OA. And GOA-ON would also like to take a small bit of time to talk about the 5th International Symposium on the Ocean in a High CO2 World. You might recall that this conference was originally scheduled for September 2020, but like so many things, it was postponed due to the COVID-19 pandemic. The symposium is now scheduled for a year from now, September 2022, and it will bring together researchers, decision makers, and stakeholders to share cutting-edge OA science. We hope everyone listening today will visit the symposium's website and stick around to the very end of this session to watch a promotional video from the steering committee. You really won't want to miss it. And without any further ado, I'd like to introduce the speakers for today's session. We'll begin with an introduction from Dr. Libby Jewett, the director of the NOAA Ocean Acidification Program. I will then go over the results from the CO2 and seawater reference materials community survey, which was put out by the United States Interagency Working Group on OA earlier this year. We then will hear an update of the resilience building and status of CRMs from the United States. We will hear from Dr. Andrew Dixon and Dr. Regina Easley. We then will cross the Atlantic and move to Europe, and we will hear from Dr. Tobias Steinhoff, Dr. Elaine McDonough, and Dr. Richard Sanders, as well as a few others, about how global efforts are underway concerning certified reference materials. At the very end, we will hear from Dr. Kim Curry, who is waking up very early to be with us from New Zealand, and she will provide a short bit of information about making sure that developing nations and lesser resource labs are provided the things that they need to conduct high quality OA research. And then finally, we're going to be turning it over to the audience. We want you to contribute. So again, please post your questions in the questions box at any time during this session. And then we'll have a more fruitful discussion that way. So without any further ado, I'll pass it over to Libby Jewett. Libby, why don't you turn your camera on? Oh, here you are. Excellent. And you can take it away.
All right. So as Mike said, I'm Libby Jewett. I'm director of NOAA's Ocean Acidification Program. I'm sure I've intersected with many of you in the past 10 years. We are a proud sponsor of OA Week, and I know for one, I'm exhausted trying to keep up with all of the presentations and community forums, and even though I'm not actually running it, I'm exhausted. But it's been really exciting. I'm also a member of the GOA-ON Executive Council. So in terms of certified reference materials, I'm just going to be very quick. Figuring out how to ensure a steady flow of high quality ocean carbon certified reference materials into the future and around the world is why we launched this effort, and we being my program and the OA Interagency Working Group, which exists a sort of a spectrum of agencies across the federal government. So that's why we launched this effort and why we're leading this national, and also helping with the quest to identify an international partner. Also, the OAP is celebrating our 10th year, and we decided this would be a really, really great birthday gift for all of us. In fact, Andrew may opine on this, but he and I started this conversation about 10 years ago. And I feel like we've got to get serious about this. So we launched the effort also because Andrew Dixon at Scripps, who's just been provided an incredible service to the broader ocean carbon research community, he should be allowed to retire at some point. And we're not saying that he has to retire now, but you know, he has to have that opportunity and not feel like he's going to let the entire international ocean carbon research community down. And secondly, and we want him to be a part of figuring out the solutions. Also, the pandemic really revealed the serious issue with one point of failure. You know, obviously, it probably would have affected any production sites, but I think having more than one is probably more resilient than just having one. So long and short, these community conversations, this one, there was one at OCB. We've had a number of them over time. We've had conversations on the OAIE, are a super important part of the process. And just finally, spoiler alert, we in the US are actually making really, really great headway on sorting CRM production version 2.0 in the US. And I'm sure you'll be hearing pieces of that in the presentations to come. So without further ado, and because we have a great lineup of people who are now involved in this effort, I'm going to pass the mic back to Mike from my office.
Great. Thank you so much, Libby. So I'm going to get right to it because we have a lot on our agenda. So I'm looking at the attendance right now, and we have over 65 attendees, which I'm really pleased about. And I hope that some, if not all the attendees, have at least heard of this community survey that was published in April 2021. So following a webinar that Andrew Dixon gave about his lab's production of CRMs, the IWG composed this and released it to the community. And we actually shared it with at least 1,000 unique individuals. And we did that by posting it on relevant listservs, right? Like, so the GOA-ON listserv, the GOA-ON website had a link to it, the OAIE, of course, all of NOAA's social media. And we also used the OCB program to help get the message out. And we received 246 individual responses. And we did kind of encourage labs to submit information as a group, right? So I'll be referring to these responses as respondents, but they're not necessarily just one individual. It could be a small lab group. The survey had 15 questions, including a few questions about demographic data, like the person's name and what lab they came from. There was no question on the survey that was mandatory, so you'll see that not every question that we will walk through has 246 responses. And there were some questions that allowed respondents to check multiple boxes. So some of the percentages that you'll see don't actually add up to 100 because people could select more than one box. Additionally, when this data was analyzed, we had fewer than 246 respondents. The survey is actually still open. So if there's people on the call that want to contribute to the survey, we could drop that into the chat and you could do that. But this is pretty representative of the survey at this point. I think we're missing about 5 responses, and it doesn't change the main message here. So I obviously won't walk through any of the demographic data that is kept all private, but the first question I will walk through is which products from the Dixon lab do you use, and select all that apply. So we've received 244 responses here. And by far, the reference material that is used the most is the total alkalinity DIC reference material, with nearly every respondent using that. About 50% were using the TRIS buffered pH, and about a quarter of respondents are using the certified hydrochloric acid titrant solution. This next question is aggregated information from one of the demographic pieces I mentioned. So in which oceanographic region do you use the total alkalinity DIC reference material? The survey really focused on this reference material in particular because we had a little bit of a priori knowledge that this was the one that most people use. After all, Andrew Dixon did help us compose the survey, so he knows he has a pretty good sense of what people are using. So as you can see, there's a kind of a few regions that are really jumping out to us. So the majority of reference materials are being used in the Atlantic and Pacific Oceans. And this is probably just showing a bias of the fact that the most well-resourced countries and labs are doing research in those areas compared to the Arctic region or the Indian Ocean, which there's not as much research going on, unfortunately, in those places. There's also the third highest region was multiple oceans or global. So that's also quite interesting that about a fifth of folks are doing research across the globe. So this next question was, what do you use the TA-DIC reference material for? And we were kind of binning these large categories. So the first two are open ocean or coastal regions, looking at long-term trends. The second two, again, open ocean or coastal, but looking at short-term trends or biology. The fifth one is characterizing seawater for biological experiments, so completely lab-based work, and then tech development and education or instruction. And we could see that the things that are the uses with the highest proportion of respondents are the coastal work and focusing on short-term trends in biology, as well as coastal work, but looking at more long-term trends. And this is probably reflective of the fact that most biology takes place along coastal regions, or at least biology that's relevant for humans. So it would make sense that those are the biggest bins here, but also about a third of respondents, a third to about 40%, are looking at open ocean trends. This next slide is actually showing the same data, just binned slightly differently. So we wanted to see who are the people who are using a lot of reference materials and who are those who are using not too few. So we arbitrarily chose 100 bottles as that number. And this is kind of how the data shake out. And you can see the people who are using more than 100 bottles, those are in the blue bars. They're definitely trending towards more long-term trend studies, as well as those who are looking at biology or short-term coastal areas. So this will really help us understand a little bit better about how to prioritize usage, and I think ultimately inform how we think about nodes of production. All right, so this next question here, it was question 12, but I think it pairs a little bit more nicely with question 7, which measurements of the carbonate chemistry system do you use the TA-DIC reference material to verify? So we have the 4 options here: pH, total alkalinity, DIC, and PCO2. And the vast majority of people are, believe it or not, using the TA-DIC reference materials to verify total alkalinity and DIC, with about half of people using it to verify pH and about a quarter of people using it to verify PCO2. As I mentioned, because people could select more than one, these 4 numbers don't add up to 100. But when we slice it out into all the individual combinations, we see that the largest group, again, no surprise, is people who are using the TA-DIC reference material to verify both total alkalinity and DIC. And this is probably reflective of the fact that, thinking to the other slides, that people are measuring these parameters both to look at long-term trends in open ocean conditions, as well as short-term, more biological-focused studies. All right, so the next question here states, how many bottles of TA-DIC reference material do you use in a typical year? And almost everyone responded to this question, and you could see that 3/4 of the respondents use less than 50 bottles a year. So a large majority of the labs are using a relatively small number. But then you do have a quarter of respondents who are using over 50, and even smaller fraction using more than 100. And we also wanted to know just not only how people are currently using CRMs, but what do they anticipate their use going into the future, right? So if we really want to build resilience around CRMs, we really need to anticipate how much more research will be taking place. So about 70% of the respondents indicated that they anticipate using more bottles of TA-DIC reference material in the future. And this is a plot kind of showing the current usage of TA-DIC reference material relative to anticipated usage. So we have current usage on the x-axis, anticipated usage on the y-axis. And you could see, I hope everyone could see my mouse, but this line with kind of the largest bubbles is the one-to-one line. So you could see that there's quite a bit of people kind of using the same amount, or at least in the same bin. But what's really important is noticing that this diagonal line that goes right above that one-to-one line, that also has a notable amount of respondents, meaning that people are expanding their efforts, and most people are kind of moving up from their current bin to the next bin up. So again, that makes all of us at NOAA and others who are thinking about CRM production, this is really useful for us because it helps us think about, okay, well, if Andrew's producing 12,000 bottles in an average year, a non-pandemic year, how many more do we really need to produce in 5 years, 10 years in order to anticipate the need, in order that we don't have bottlenecks? So this is another issue that we've heard about a number of times throughout this kind of CRM resilience roadshow that we've been taking around for the last 8 to 12 months, is the complications with using mercuric chloride in certain countries. So question 10 asked, is it challenging for you to receive shipments containing mercuric chloride? And the vast majority of people said, no, it's actually not a problem for us to receive shipments of this poison. Although I think it is still notable that almost 20% of people did have a problem. And thinking about question 11, does the country where you use TA-DIC reference materials have procedures in place to safely dispose of this poison? Again, the numbers are kind of the same, but flipped, where about 80% said, yes, we have safety procedures in place. We could deal with this poisonous substance. But about 20% of folks actually said, no, either we don't have procedures, or probably worse, I'm not sure of what those procedures are, which could either lead to two issues, right? It could lead to improper disposal, or it means people storing the materials kind of indefinitely and probably inappropriately. So this really opened our eyes, and as I think really needs to be an area of more active research and thought as we move into the future. All right, and I think this is the last slide here of this overview of the results. It is, are you confident in your lab's ability to produce a secondary standard for your laboratory's CO2 system measurements of seawater? And I think this is an area of action that we could definitely improve upon. So, 56% of people said they weren't confident in their abilities to produce a secondary standard. This needs to be addressed. And I think Kim Curry will talk a lot more about the need for secondary standards, and also the need for the development of standard operating procedures to do that. And hopefully in the next few months or years, something like that will kind of enter enter the community's resource pool. And I think that brings us back. And so if anyone has any questions for me about this survey, please type those into the questions box and just use like the @ symbol and direct them to me. And again, if you miss anything or you want the full picture, we will be typing this up and putting it on the OAIE, the OA Info Exchange, relatively soon after this session. Now why don't we move over to Dr. Dixon? So Andrew, you could turn your camera on at this point and I will control your slides.
Thank you. So I'm going to tell you a little bit about what we do at Scripps for reference materials, but more some thoughts for the future. And we'll start out just by saying, what do we mean by a reference material? Next. Next. Thank you. So a reference material, essentially, you can see in red here, a homogeneous, stable substance for which one or more properties are established sufficiently well to calibrate a chemical analyzer or to validate a measurement process. So that's really what we've tried to produce in my lab in regards to CO2 measurements in seawater. And we'll tell you a little bit about where we stand now on that, but we're mostly here today talking about how we can move forward from where we now are. If you want more information about our past history, the presentation I gave about 6 months ago, which is online at the NOAA Ocean Acidification website, fills you in on that. Next. So my lab at Scripps has been supported by the US National Science Foundation for over 30 years. We got our first money as part of JGOFS, I think it was in 1989. And in that time, we've prepared so far 198 separate batches of our CO2 and seawater reference material. We'll be doing number 199 next Friday, not tomorrow, but a week hence. And we've calibrated these for total dissolved inorganic carbon since the early days, 1990, and about 6 years later also for total alkalinity. We also provide information values for salinity and nutrients and on request pH. The third comment, 6 of these batches were unstable. Obviously, to be useful as a reference material, it has to be the same every bottle of the batch, and it has to stay the same for a protracted period of time. So you can calibrate it and then ship it to somebody who can then use it. And 6 of our batches during that time were not stable, probably due to a mercury-tolerant organism getting into the batch. We've had that quite commonly in other areas. Another one of these batches had problems actually with the alkalinity being quite variable from bottle to bottle, and we think we had a batch of bottles that were in some way damaged that caused that. And we gradually grew in how far we did this. In 1990, we did a batch of 100 bottles of reference material. By 2019, we were doing a batch of about 1,240 bottles, and we're doing multiple batches a year. As you see here, the comment, we did over 11,000 bottles in 2019 alone. But since 2010, we've also added additional reference materials to help people. Calibrated alkalinity titrant, which is an HCl that you can use for alkalinity titrations, and also tris buffers that help to define pH-T. And in addition, on behalf of NOAA and others, we've produced samples that have been used for proficiency studies. That is, they're used as blind samples for people to analyze. Next. So the COVID era. Well, we, like everybody else, ran away from the university in March of 2020. And although we were allowed back to work in the lab after about July of 2020, we were not allowed to ever have many people together in the same room at the same time for a protracted period. And that made preparing reference materials pretty well impossible, as it was not something that was straightforwardly done with only a single person being there. But we started really at the beginning of this year with a batch with about 2 people at a time being there and two batches of 2 people. And we've increased that till batch 198 was actually 4 people in the lab and 2 lots of 4 people each working for a while to get things done. And that's where we are at the moment, which is our usual size. And but we've still got a lot of people going, please, can we have reference materials? An extensive waiting list. And we're therefore saying to these people, on the whole, yes, we think you can, but no, we probably can't give you as many as you would have wanted until we're properly caught up with this backlog. And our current limit to increasing our production is not just the practicality of making the batch of reference material, it's the fact that we don't actually have any empty bottles to use. New bottles are on back order and have been on back order now for many weeks. And only a limited number of bottles are coming back to the lab for reuse. And so I urge any of you that have bottles to consider sending them back to us. And we'll make a note, of course, with regards to the bottle credit, and we will make more CRMs as quickly as is practical after washing them. Next, please. So what's the possible future or futures? Well, as I said at the beginning, our program at Scripps, funded by the US National Science Foundation, is funded until about 2024. So, you know, basically at least another 2.5 years, really. Next. So, as we look forward, I think it's important to just stop thinking about this as, oh, let's just do more and more of the same, but ask what changes in what we do might ultimately be beneficial and think how we could achieve this. We use these glass bottles. They work well. They are heavy. They are expensive. So a lightweight, single-use, flexible packaging that doesn't use grease needs to be developed and tested. We've tried a few. None of them have obviously worked, but probably because we haven't tried hard enough because we've been so busy making the reference materials. The comment earlier from Michael about mercuric chloride is true. An alternate preservation method needs to be developed and tested. We've done some work on this under the support of the NOAA OA program, but that work has really been for storing samples for short periods of time. It needs much more extensive testing and probably additional work to consider it suitable for storing a reference material. And we think ours with mercury are stable for at least 3 years. And that's what I say, then if you do that, you have to have the work to understand really the stability. The 3-year number kind of works because some people keep them a long time, but we keep producing, as I said, about another 10,000 a year. But the expense of doing 10,000 as essentially 11 batches is you're going to have to calibrate every batch separately. So if you had a much larger batch, then it would be more efficient to calibrate it, and you could possibly imagine having an automated packaging process. But you can't necessarily make a larger batch unless you're sure they're stable. And you waste of time going into a more efficient packaging process until you've got a better packaging. So these feed on to the early parts and start to bring up the possibility of there being benefits of separating the production and the distribution of such reference materials, which is a full-time logistic task to achieve that, from the certification, which is a much more technical chemical analysis task. And then people said, oh, please, we'd like to have it properly certified for PHT, or the 13 carbon level in the total carbon. Is it worth doing that? And what extra work is involved? And as was commented earlier, the COVID made really clear how fragile this production and distribution system is. So any future plans need to worry about the resilience of these supplies. Next. So what possible alternate futures are there? Well, one, we could just continue at Scripps and continue seeking the money from US federal agencies and from individual purchasers of the reference material, which is how it's done at the moment. You could imagine moving part or all of the process. And as I say, there's really 3 separate parts: the manufacture, the certification, the distribution, to a new US location, or maybe more than one location. It's probably, as was noted, important to establish locations outside the US that can also produce reference materials, where it's also going to be very important that there's a consistent quality across all the production sites. That is, that the reference materials are just as stable and just as similar from bottle to bottle from either, and that ideally, that if they're independently calibrated, there is comparability of calibration. And work has to go to achieve and test these things. And none of this addresses really sustainability, which means how you're going to be sure the equipment is always working, how you can be sure the people are always working, that the equipment is in good condition, that the people are trained and available. And resilience, which is that still harder word, which is, and when there's a big problem, how long does it take before the fact that problem happened doesn't really matter for the larger oceanographic community using the materials. Next. So we got to consider the balance between the value of these materials and the cost of these materials. And I've noted here 4 groups that ought to care about this. The science people, of course, like yourselves, the potential sponsors for this, and the people working, producing reference material. And when I say customers, I'm really saying the small subset of the scientific community who really use these on a more day-to-day basis. Next. We also, of course, need to emphasize the benefits of having these reference materials well against their costs. And here I'm really saying exactly what kind of reference materials does the community really need? We've seen what we've produced. We've heard desires for more, but everything you do more costs more, and balancing benefit and cost is important. Sustainability clearly has a benefit, but it has a cost because you probably have to have people already trained or being trained to take over at the same time that you're paying other people to do the work. And so it costs a little bit more to achieve that. Resilience is largely the planning and thinking about possible ways it could go wrong and how you're dealing with that. That's much harder to really show you succeeded until the problem happens. So next. So this is the end point. I feel it's important, and this is what I hope we'll talk about today, to seek a community consensus identifying what's needed, whilst explicitly recognizing quite how much that's really going to cost. It's a balance between getting what you need and paying for it. So thank you. Next. I'd just like to say thank you to the many institutions and individuals who made sure we got to this point. The US National Science Foundation, who, as I said, have supported it for over 30 years. Professor Charles David Keeling, who died now about 16 years ago, and who encouraged me at the very beginning to go into this work. Other US agencies like the US Ocean Acidification Program and the Department of Energy, who have been involved and interested in the success of this work, and SCORE, who also have been the same, and my own institution, who have helped through ensuring we had the facilities available to make this happen, and that we had people to actually send you all the notes saying, please pay the invoice. Thank you.
Hi, everyone. So our next speaker is Regina Easley. Before we hear from Regina, I just want to thank Andrew for speaking and sharing those thoughts with our community. And I also want to remind the audience that this is an extended community discussion session. So we actually are going to be running until about 1:30 today. So I hope that you all can join us for our full session. Okay. Regina, you can take it away.
All right, thank you. Thank you all for the invitation to speak. My name is Regina Easley, and I am a research chemist at the National Institute of Standards and Technology. I'm also a member of the Interagency Working Group on Ocean Acidification here in the US. And we have been talking a lot about developing a node within the US for carbon dioxide reference material production. Next slide, please. So one of the benefits of working with the metrology institutes is that we have a history of sustaining reference materials for decades. It's like really tremendous what Andrew has done for the ocean acidification and really the ocean chemistry community. And alongside of that, we recognize that at some place like NIST, we have had a history, for example, in our pH standard reference material programs of running programs for decades. Our pH reference material program has been in existence for about 76 years, and we perform those measurements using some of the primary measurement capabilities that we have available here. Next slide, please. In thinking about this tremendous issue of succession planning, we realize that one of our current limitations is that Andrew's lab produces an enormous volume of reference materials per year. Before COVID, we know that his production level was about 10,000 bottles per year. For NIST, our SRMs typically sell about 86 units per year, so that's a huge difference in terms of the volume of materials. Next slide, please. Another thing that we're considering are are some of the available measurement capabilities that we have, and what would actually be needed in order to do the quality of measurements that Andrew is producing. So currently, we do not have a manometric system that's established here for primary carbon dioxide determination. We do, however, have capabilities and expertise in our gas metrology group. So we actually have been discussing with our gas metrology group within the chemical sciences division here at NIST, how we can establish this capability, which is similar to a setup that Andrew has in his lab. And the idea is that we would start a program which is very similar to the gas metrology group's NIST traceable reference material programs. And I'll talk about that just briefly in a few slides. Can you forward one, please? Another limitation that we have is that we are landlocked here in Gaithersburg, Maryland, so we don't have access to seawater. We don't have the luxury of being on that beautiful San Diego coast, and so getting access to seawater is absolutely a limitation. Next slide, please. So given that we don't have access to seawater and we really don't have the capabilities of producing high volumes here, we have been in discussion about establishing a NIST traceable reference material program for seawater, which is similar to the program that is already established at NIST for gas metrology. With this program, the way that it operates is that NIST works with specialty gas companies who produce large batches of cylinders. NIST provides certification on a representative number of samples from each batch, and we issue certificates of traceability for the batches. And if you look at that diagram to the left, the uncertainties on those cylinders is pretty equivalent to our standard reference materials. The specialty gas companies are responsible for all of the stability testing and the distribution of the samples. But on the NIST end, we are responsible for overseeing the process and for maintaining the primary measurement capabilities here at our facilities. Next slide, please. So the one question that we have been discussing is how would this model, or what would it look like for an oceanographic reference material? The reality for our gas group is that over the past few years, they have certified over 2,100 gas mixtures at this level. But what having this type of partnership does with it actually increases the volume that they're able to provide in partnership with the specialty gas vendors to the air quality community. So the specialty gas vendors produce about 5,100 SRM unit equivalents per year. So it's a partnership that works well. We have established procedures for working this type of program, and we would like to, or our intention is to work with our gas metrology group to learn more about how their program is actually organized. Next slide, please. So what we imagine that this would look like is that there would be possibly multiple bottling facilities across the US, and I just arbitrarily picked the West Coast, the East Coast, and the Gulf of Mexico. Those facilities would be responsible for acquiring batches of seawater and doing acceptance testing to make sure that they are stable. They would also perform homogeneity assessments, and they would be responsible for the distribution and the stability assessments that are needed to ensure that the batches remain stable over time. Each one of those facilities, when they produce a batch, they'll send a selected number of bottles to NIST, where we will do high quality measurements on alkalinity, DIC, auxiliary reference measurements, and then also provide a certificate for each batch, which includes the uncertainty budget. And we'll also work with the community to refine the certification testing process. You can advance, please. So questions that we have are, is this feasible? What will it cost to start bottling facilities if we decide to go along this pathway? And how many additional staff members will we need? So that's additional cost as well. For us, we think that it's feasible to start with capabilities that we can easily acquire. And those are maybe making value assignments for auxiliary reference measurements and alkalinity titrations. Those are the lowest hanging fruit at this point. Next slide, please. The other component of this type of program, this NIST Traceable Reference Material Program, is that in order to do this efficiently, it's really important to make sure that the process for producing standards and establishing the traceability is well documented. In the gas metrology space, this is evidenced in this EPA traceability protocol. And what this outlines is the ways that calibrations are established by the production lab. It gives guidance on providing uncertainty budgets. It also gives guidance on how do you perform batch instability test, and what criteria were you established to know whether or not your batch is out of spec. So we think that definitely a protocol of this sort would be of great help to the community moving forward. Next slide, please. So I'll thank you for your time, and I do welcome questions. I'm definitely not working alone. In addition to the Interagency Working Group on Ocean Acidification, Jason Waters and Michael Winchester have been involved with these discussions. Thank you.
Thank you so much, Regina. We really appreciate and are excited by NIST's involvement in these efforts. Let's now hear from Tobias Steinhoff and quite a few others from Europe and around the world who are going to be talking about efforts outside the United States. So Tobias, you could take it away. And when any of the other presenters need to join, feel free to unmute yourselves and turn your cameras on as well.
Okay, thank you, Mike. Yeah, as Mike already said, the title here might be a little bit misleading. It's not really a European view on the situation, and as you might see on the list of speakers, which is a little bit the order how we share this talk. We start with a European view on the situation and describing a little test balloon that we started, and then move over to a more international point of view to the whole situation. Okay, next, please. So I was talking about the test balloon. So in Europe, we have an research infrastructure called ICOS, Integrated Carbon Observation System, and which has an atmospheric, terrestrial, and oceanic domain. And when we talk about here the CRM for marine CO2 measurements, of course, I'm talking on behalf of the oceanic domain, which has a thematic center. It's called OTC, which a little bit coordinates this network. So this network in Europe consists of 23 stations. There's a ship of opportunity measuring CO2 in the surface water, but also fixed ocean time series stations that measure the carbon chemistry at a fixed point. And it's very clear that this community is very dependent on CRMs, which we of course also get from the Dixon lab. And I guess, sorry to Andrew, I guess we store a lot of your bottles right now in Europe. Okay, but as you can see, this yeah, no, it's okay. This network got hit very hard by the shortage of CRMs, and we as the ICOS OTC or the ICOS community had to find a solution for now. Next, please. And our solution was just preparing a substandard at the time where we still had Dixon CRMs in our lab standing around, that we could somehow reference our substandard to the international standards, so to say. So we used 350 liters of seawater, poisoned it, homogenized it, and filled it in sorry, CRM bottles, and also a lot of other sample bottles that are not original CRM bottles. And they were measured on a colorimetric summer system for DSC and the winter system for alkalinity at GOA-ON Kiel in Germany. And the values don't matter, but the uncertainty is approximately double the one that you would get from the Dixon lab, of course. As I said, we use Dixon CRMs for referencing. We did a short-term stability check, so we did the pre-test for 3 months, and it looked stable, so we then decided to go for it. So we pre-certified the bottles, but we still keep some bottles, and we have to discuss with Andrew if he would be so kind to measure some for us, so that we can actually see the real value, and I mean, hopefully it's the same that we measured. We distributed it then to all the ICOS stations. It was free, but also other European stations, of course, were in urgent need of the reference material, and we also shared it with them. So far, we sent out 250 bottles to 11 different labs all over Europe, and we have something like 100 bottles left. Next, please. So very important. This was really not meant to somehow replace the whole Dixon lab. This was really just a crutch to overcome the CRM shortage. And one should know, I mean, we now gathered some experience what it would mean to make a reference material like this. But this exercise was only possible because we found a cubic meter of seawater that was standing around that we could use. Of course, our substandards have a limited quality. It's not this quality that we can get from the Dixon lab. And if we think into the future, the question would be how many labs in Europe are even equipped to make this kind of measurements with a sufficient quality. Okay, next, please. So the whole situation, of course, made us thinking about how could we solve this. I think the discussion that we need, in addition to the Dixon standards in the future, is not new, but as everything with COVID, it made it very clear. So, and one idea which doesn't mean to really replicate the Dixon lab all over the world, but one idea we came up with was that the Dixon lab, or some successor of this, still exists there, does a primary CRM with specific water, and we might establish 1 or 2 or even more. This is really just an example that you see here. I call it now Europe lab, and Asia, Australia lab can be anywhere, and the name is not important. But that we have one lab in the US, the successor of the Dixon lab, making the primary standard, and other labs do the secondary CRM, which even can be then done with local seawater. so not only Pacific, but even Atlantic or Mediterranean Sea or wherever these labs are sitting. It produces secondary standards that are, of course, traceable to the primary standard with a little bit of a lower quality. You see it in the orange boxes on the top. It's approximately what we think we can achieve with the methods we have in a good CO2 lab. And of course, these labs then have to talk to each other. I mean, there needs to be a cross-validation of the other CRMs and a second referencing by the Dixon lab of the standards that are getting produced. And the idea of a situation like this could be that also the distribution system could be then a little bit along the longitude, so that one lab is really responsible for the American continent, one for Europe and Africa, and one for Asia, Australia, a little bit, just roughly. Okay, next, please. And of course, it's important then each lab would need to have the same task. So they had to provide seawater, which was already mentioned as a problem. They have to have the possibility to even get seawater. They have to filtrate, sterilize it, following agreed protocols. They have to provide the CRM bottles, as Andrew already mentioned, which is also a bottleneck. They have to be able to fill the bottles following agreed protocols, so that we do actually everything the same, but the DIC-TA analyzers has to follow agreed protocols. They can be different, but of course they must be well documented. And every lab has to take care of the logistics, because this also should not be underestimated, as Andrew said, asking for the payments and looking for where the bottles are, and so on and so on. Just some open questions that might be answered later or not. How is it for the pricing? Should be the pricing the same for all the labs, different qualities, different prices or whatever. And we definitely have to think in the future for possibility for reduced CRM prices for countries with less financial possibilities. Next, please. And here I answer one European view on the situation and hand over to Elaine. Yeah, thank you.
Thanks, Tobias. Could we move on to the next slide, please? So MyCheck asked me to give a perspective from GOA-ON on what the change in availability of CRMs has meant for us. So GOA-ON is a global observing network for repeat hydrography. We make these 55 sections, as these are our reference sections, and they are occupied once a decade. Each section is coast to coast and full depth. And on a section, we might typically make several thousand observations of carbon parameters. So GOA-ON is really probably a large part of the constituency that Mike referred to, that was the deep ocean long time scale, which was not by any means the largest constituency, but had a very high CRM use. And the reason that is because we require incredibly high quality observations to make them useful for the climate for the climate studies that we do. They're relatively sparse in time, so they have to be very high quality to be useful. Okay, so GOA-ON utterly relies on CRMs, you know, shown by our very high usage in that survey results, and really the lack of CRMs is very high on our risk register. Okay, so next slide, please. So this is just about CRM availability. I don't think we need to do that again. We know that there's been issues. Okay, so I asked so these 55 sections are occupied by 10 nations, and I asked those nations to tell me what the issues around the lack of availability had been, and so the impact of that is reported here. So multiple investigators are making secondary standards, where in the normal course of events they would use these the primary CRMs. people are storing samples, which both has an impact on potentially on the quality of the analysis ultimately, but also is having knock-on logistical effects, both in terms of you know, space to store the samples and the human resource to analyse them. There's also people exploring other possibilities using fewer standards overall, which is counter to our GOA-ON protocol, but you know, necessary in the circumstances. This is also a threat to data quality ultimately, and there's also countries thinking of reducing their sampling density so that ultimately there will be fewer observations in the deep ocean. Next slide, please. So the suggestions that these investigators came up with when I asked them about this was, we had one response that said that there's no problem, they hadn't experienced any issues, and they were actually concerned that that an additional or more dispersed reference material supply network would jeopardise the very high quality that everyone is used to and thankful for. That was one response, but all the others were keen to see an additional supplier, you know, particularly to stabilise the CRM availability and to kind of build some of this redundancy and resilience into the system that has been, you know, have several people have said already, been really strongly highlighted by the pandemic. Geographically distributed bottling facilities was another suggestion, and also because of the very widespread use now of secondary standards, some protocols and standard procedures for their production was another suggestion. So I was also made aware that of a company Kanzo in Japan, which is making reference materials, but they're not certified. So that may be a kind of a slightly more oven-ready solution. Next slide, please. So one of the reasons that that MyCheck asked me to talk as well is that at the moment I'm building a consortium for a Horizons Europe infrastructure proposal that we are looking into how we can support the work on CRMs, you know, within this infrastructure proposal. So this is a European GOA-ON proposal, and we will look to include some element of support for CRMs in that. And I look forward to there being some kind of outcomes from this meeting and the subsequent workshops that I understand are planned to see what the most useful way we can contribute is. That's all I wanted to say.
Thank you very much, Elaine. And we'll pass that over to Richard now.
Hi. Good evening, everybody, and thank you, MyCheck, for asking us to offer a few perspectives. We've been speaking about it. My name is Richard Sanders, and I work in the ICOS Ocean Thematic Centre along with Tobias as well. My perspective on this is that this was a crisis that was coming for a while now. The system didn't have succession planning that was strong enough and didn't have enough capacity. COVID just exposed the weaknesses of the system. So we can't think to ourselves it will all be all right post-COVID. Some might think actually that the word crisis is a bit strong, and I did wonder about that. But actually, when you think about it, measuring the amount of carbon dioxide that goes into the ocean, how it varies in space and time, is a key part of understanding how the ocean regulates our climate. And given the severity of the climate crisis, I don't think it's well, for me, it's not inappropriate. So things that we've been thinking about and talking about is it our ambition to replicate Andrew Dixon's lab operation in multiple centres, or to rethink the whole system? My perspective is that there's an awful lot that's very, very good about what we have now, what we had pre-COVID, and this is not a wheel reinvention thing. This is a evolution, not a revolution sort of system. Regardless, in my view, of what the final plan is, a substantial investment is going to be needed. And if I have one message that I think I'd like to offer, I think it's just basically that. This will cost money, and somebody has to pay For me, the benefits are very strong, but ultimately it will cost. And that means that somebody is going to have to invest. And some combination of governmental sources or a commercial entity, there are examples of both working well, will need to step up. And I think what we as a community have to do is to create the environment where one of those entities has the confidence to put the money on the table to build the systems that we want them to build. And so I'll just finish by saying what's key is for our community to agree what we require to deliver a fit-for-purpose system to support the science we need for the ocean we want, and to indicate what it costs, so that we can work with funding agencies to build that cost into their forward spend planning. I suspect that in the future, the true cost of supporting a robust, resilient system will be more than what we pay at the moment. For me, that's a price that it's worth paying, but we need to define exactly what we need before we ask our funding agencies to support that. And I'll stop there. Mychak has a few more perspectives, I think.
Yes, hello everyone. My name is Maciej Tolszewski, and I will present a couple of points really on behalf of the global ocean carbon community. These 2 points I want to make are along the lines of the value versus cost consideration that Andrew Dixon has proposed at the beginning of this presentation. Could I have the next slide, please? So the first point, it's about the value of the CRMs that needs to be really appreciated and widely communicated during these discussions today and also into the future until we solve the current crisis. I would say, I would agree with Richard, it should be called crisis. Is that the CRMs allow us to make climate quality observations from ships, and that has truly transformed our ability to quantify the uncertainty in these observations. But that's not the only quote unquote, that's not the only benefit from using CRMs. These climate quality observations are a fundamental validation tool for measurements done by other means, specifically including the BGC observations from Argo array. And as such, they provide an indispensable element of the whole observing system for marine biogeochemistry. The second part of this point is that our data products, data synthesis products, as well as model projections, are ever more reliant on biogeochemical observations from Argo array and other platforms that do not allow the CRM use or analysis in situ. Therefore, we absolutely have to make sure that these observations can be validated using ghost ship observations made with the highest possible accuracy. So this whole point for me indicates that we're not only talking about the ocean interior carbon observers from ships. We are talking about the whole understanding of ocean carbon based on observations from a variety of platforms. And these other sub-communities need to be included in this discussion, at least when the resourcing is on the table. The second point, which is on the other part or end of the spectrum of the value, is that the researchers worldwide make those observations for a variety of purposes, and not all of them require climate quality data. And this situation we are in now is an opportunity, in my mind, to agree on the standard operating procedures for these observations that perhaps can be accepted with higher uncertainty on them. But when discussing those SOPs, we need to take into account the limited resources resourcing in many parts of the world. On one hand, on the other hand, our global need to know the uncertainty of the data shared. Whatever the uncertainty might be, it's always better to know the uncertainty than don't know it at all. Currently, and that's before COVID, observations are being abandoned or data is not being shared by colleagues from several research groups, mainly due to their inability to follow the GOA-ON protocol regarding the use of CRMs, which is mostly based on the fact that they simply can't afford using CRMs in amounts of volumes that would assure the quality of data that's protocoled by GOA-ON. But still, I think in our discussions, it's the highest time for us to decide whether or not we are happy to accept the data with higher uncertainty, with a specific flagging system, as we've done in many data synthesis products, etc., etc. So this inclusiveness, I think, it's time for our to sit at the table and discuss the protocols, how to go about it. Thank you very much.
That's a nice segue, Magic, and thank you for sharing that. And thank you to Richard and Elaine and Tobias for sharing your thoughts. I do just want to give Kim Curry a platform. So allow me to bring up her slide. Okay. Good morning, Kim.
Kia ora koutou. Good morning, everyone. Thanks for the discussion, and I'm really pleased to hear that a lot of the points that I was hoping to make have already been covered, but I'll just quickly go through as well. The pointing out the need for reference material of lesser quality, perhaps, but for developing and lesser resourced labs. So the cost of the CRMs currently is a barrier to many labs, not just the cost of the CRM itself, but also the freight cost for the getting the material to the lab and then returning the bottles and the crates. With the increase in the number of labs that are doing measurements, particularly I'm thinking of GOA-ON and a box recipients, smaller labs, many lesser resourced countries, the access to CRMs currently and in the future is an issue for them. And I think this will only increase, and the respondents to the survey that Mike talked about certainly indicated that. So just endorsing what's already been said before about the need for a secondary standard system that's really robustly linked to the CRM, the primary standards. So it seems like listening to the talks today, but also talking and being familiar with labs all around the world, many labs produce an in-house standard or a secondary standard using a variety of protocols and methods. There doesn't seem, everyone seems to think that their way of doing it is okay, but there's no particular standard way of doing that, and there's no particular method of assigning the value to that secondary or in-house standard, and a lot of them use it for lab management applications. So I think that along with this process of the primary CRM development and production and expansion, we need to develop more of a protocol for producing the secondary standards on a regional basis, including how a value will be assigned to that secondary standard. And a method for developing a system for producing these secondary standards in bulk and production, and I thought that the GOA-ON regional hubs could be a method of doing that, but there's been other suggestions already talked about today. And then I think for those labs or those projects that are using the secondary standard, there needs to be some wider community acceptance of that standard and how it's used, and so that would be how it's used in, for example, publications, people how they quote that, how it's then reviewed in publications, how it's flagged for things like submissions to the SDG 14.3. But I think the key thing is that it goes hand in hand with the CRM process, and that it's a robust and internationally recognised process. Thanks, Michael.
Thank you, Kim. And at this time, I'd like to invite all of our panelists to turn their cameras on, and we could begin a Q&A segment of this webinar. I'll also invite the audience to once again ask questions in the questions box. If you have a question for a specific person, please make sure to indicate who that person is. And I'm just going to be pulling up the questions here. Okay. So the first question we have is for Regina, and the question is from Alexis Valori-Orton. She asks, is NIST considering supplying CRMs to the international community or just to the US community? And kind of off that same point, Melissa Melendez asked if NIST had a sense of how much the cost of the CRMs would be if they were being produced by NIST. So how much would they cost, and are they going to be available internationally?
We do not have an estimation of the cost right now because, you know, there are startup costs that are involved, as well as costs for additional staff members for making those reference materials. And for us, they would be available to anyone that needs them, not just within the US.
Great.
The one limitation I should say is that I'm not sure we can produce the capability to supply things fully globally without other partners. So that's why our main focus is the US.
Absolutely. So another question we got is from Craig Neal, and it's to Andrew Dixon. Craig asks, if a batch is going to go off, how long does it usually take? And at what point in time can one trust that the bottle will remain stable, say for 3 years?
Our experience has been with the problems we think was a mercury tolerant organism, that happens quite quickly, and that normally could be detected as happening within 2 weeks of bottling. But we normally look at a batch for at least 3 months in the way that was noted earlier. And we have far less knowledge really about every batch out at the 3-year period, because the need for reference materials has been so high. We're pretty well out of a batch within months of having certified it. And if we kept some back, then ideally we'd have to make more batches per year. And at the moment we're paddling, in 2019, we were paddling as fast as we could. We still are, it's just we're not paddling as fast.
Totally understood. So the next question is coming from Valentina Amaral Acosta. And this is kind of a question that a few people have. And Valentina wants to know, is there a published secondary protocol out there that can be found? And if so, can it be shared? I know this has kind of been touched upon by a few different people. Maybe Tobias, you could talk to this.
I mean, I'm not aware of a protocol like that, but I have to also admit that I didn't really search around. I knew some people that worked in Andrew's lab and had them there in Norway, for example, and they gave us very insightful tips, and then we did it like this. But I agree, I guess this is what I meant when I was writing down to the need to follow agreed protocols. And the exercise we did is to see as an ad hoc solution, a little bit, I would call it a little bit panicking and then doing it. But if one would like to replicate a little bit the way we did it, or we would like to replicate it, then we have to find some protocols to do that. So yeah, I'm not aware of one, but I totally agree. It would be great to have something like that.
Absolutely. Magic, go ahead. You want to contribute?
I do, but I think Andrew had a point too, so I'll let him speak first. Andrew, please.
My point was that we have a detailed description of how we ourselves prepare these, but it's a description intended for reference within our laboratory. It's not written cleanly and clearly as a protocol. But our sad experience was that it worked fine at first, and then it went downhill, and it took a while to get it where we were sure it was likely to work fine every time.
Thank you. And my point was, I'll just reiterate what I said on my slide, my second point. At IOCCP, Goose Biogeochemistry, we are very, very happy to push forward the activity towards developing a community-agreed protocol for secondary standard production if the community decides that the secondary standards is the way it wants to go. Thank you.
Thanks, Magic. So the next question we have is, I think, more along the lines of evolution versus revolution, but it has to do with a little bit more of a technical point of something. So Cecilia Schappa asks that, or states that she's from Mexico, and a large part of the cost of acquiring a CRM is the importation taxes. Is there a way that either through GOA-ON or the IPCC or some other kind of treaty or compact that CRMs could be tax-free? And if we're thinking about the evolution of CRMs, perhaps that's something that is a technical detail that needs to be considered. Anyone want to tackle that? Maybe this is going into the realm of politics and policy that's maybe a little bit outside of our sphere, but
Mike, I'll just say that maybe this is a great example of why the UN Decade effort could be helpful, because that's more of a government-to-government effort, which might be able to help address issues like this.
Excellent point, Shalyn. And if anyone missed it, GOA-ON's UN Decade program, ORS, we had a webinar about that just an hour or so ago. If you weren't able to view it, we'll be on YouTube, and there's a lot of information on the GOA-ON website. So we will definitely bring this question to our ORS steering committee for sure, Celia, or CC. Another question that has come in is from Dwight Gledhill. He asks, if reference waters are being collected from a range of ocean basins by the community, is there criteria we need to consider regarding how and where that water is obtained? Any person want to tackle that?
I would say,
Sorry.
Oh, go ahead.
Our own preference was to collect water that was as apparently clean as possible with low nutrients as a starting point. And that has, on the whole, worked out for us. We've seen clear problems where we took the water from inside the Scripps seawater system, where it had added goodies due probably to microbial growth in all the pipes.
Okay. Anyone else have anything else to add? Regina, did you want to chime in?
I was going to say, I think it would be good to defer to or refer to Andrew's experience with that. But I think that there should be some sort of kind of standard protocol about how water should be taken in as well as processed.
Absolutely. I'll just mention that in the questions or chat, Alexis Valori-Orton mentioned that the Ocean Foundation is interested in working on the elimination of duties of CRM shipments, and she's looking at regional conventions. So it's definitely got the attention of some groups that are hopefully making moves on that issue. So I'm just checking the clock, and we are coming towards the end of the session. So I think I'll ask our audience if you have any other questions, please post those in the questions box now. And what we'll do is take all of the questions we didn't get a chance to answer and post them on the OA Info Exchange, where we'll continue this conversation. I want to take this opportunity to really thank all of our speakers today. I think this was the session that had the most panelists on it, which is probably warranted because this is such an important issue that really is at the foundation of ocean acidification science. So thank you all for taking the time to produce presentations and to be here with us today. I also would like to thank our audience for watching this session and really encourage you to continue asking questions, be a part of this evolution, and join the OA Info Exchange if you haven't already to continue being a part of our conversation. I'm going to leave everyone with a promotional video from the steering committee of the symposium, the High CO2 Symposium. Please stick around to watch that if you haven't watched it already. All right, thank you very much, everyone, and have a really good rest of your day.
Thank you.